Good evening, everyone. In the last two videos, I think we are talking with respect to queue data structure. Okay, we are discussing related to the queue data structure. I explained very clearly. So, what is mean by queue? Okay, how these queues are implemented? Okay, there are different types of queues are there, like a normal queue. That normal queue, how you can able to work, I explained very clearly. Even we have circular queue is there. So how to implement that circular queue also we discussed very clearly in our last videos. Okay, so normal queue implementation by using arrays. So normal queue implementation by using linked list, I think I have not covered. Sir, we will see now how to implement this normal queue by using linked list. Okay, so normal queue implementation by using linked list. Okay, I want to implement a normal queue by using linked list. Let us see how you can able to implement this. Okay, right. Listen, friends. So normal queue means we know, right, how to perform insert operation, how to perform delete operation, all these things the basic examples I have already given. Even we have seen that array list implementation, I mean array implementation also for this. Now I want a linked list implementation of this. Now sir, I'm creating a new class normal queue by using list. What variables are required if you want to implement this? What variables are required? Sir, I need two special variables, like I need two special variables, like we need to go for front and then rear. Okay, of type node. And even size of this list is also required. Of course, it is not static, it is dynamic. So whenever a new object got inserted into the queue, we are incrementing this size by 1 unit. Whenever an object is deleted from the queue, we are decrement this queue by 1 unit. So now I have class node is there. Within this, I'm taking integer data. So node next, I'm taking next pointer node integer. I'm going to take a data field and then I'm going to take a next field. So this dot data is equal to this dot data is equal to I'm taking data, and this dot next is equal to I'm giving next. Right. Sir, a class node is there. Even I need to write a constructor for NQ list. So this constructor is going to assign front value is equal to null and rear value is equal to null. And what about initial value of size? 0. Like this, a new constructor whenever we are creating an object. So for that normal queue, this is nothing but the default values what we have. So now I will start implementing the functions. What is the first function? Sir, I want to display the elements. I'm going for display function. How you can able to display the elements? Then to display system.out.println of my queue is empty, and immediately I'm going to return the otherwise. Okay, otherwise what is happening here? Sir, can you please confirm, is my voice is clear for everyone? Please confirm. Because sir, some network issue is there from my side from the past 2 days. So it will be resolved tomorrow because we shifted the house. So from one location to another location. That's why I'm taking the class with my mobile internet. That's why a bit delay you can expect it today. Please try to cooperate. So tomorrow it will be resolved. Okay. Right. Yeah. Now Sir, display function q is empty. Otherwise, what we are going to get? We need to display all the elements, right? For that, I am taking node temp. Okay, node temp. That temp is always pointing to front. So while your temp is not equal to null, okay, while your temp is not equal to null, sir, I am printing the content present in this temporary node. So temp dot data and the next field. We have to transfer the control to next field or not? Yes, sir. So temp is equal to temp dot next. Like this, we are traversing something like displaying the elements in the single linked list. Beyond that, nothing, sir. Okay. Anyway, I will show you how it is going to work. Have a look once. Suppose consider I have a normal queue is there in this state. Okay, sir, this is nothing but the first node what we have in my queue, and this is nothing but the second node what I have in my queue, and this is nothing but the third node what I have in my queue, and this is nothing but the fourth node what I have in my queue. Like this, I have some four nodes are there inside the queue. In this style, last field is null, and its next field is nothing but this one. Its next field is nothing but this one. Its next field is nothing but this one. So consider this data is 10, and this data is 20, and this data is 30, and this data is nothing but 40. Like this we have. So now, sir, what is the size initially? How many elements are there? Sir, we have four elements are there. So it is not empty. So this pointer name is nothing but what's our friend. This last node is always represented with rare because I already demonstrated these technologies. Whenever a node is inserted, a rare pointer will move. So whenever a friend node, I mean, whenever a node is deleted or an object is deleted from the queue, friend will move. Okay. Now, sir, we are maintaining a separate pointer called a temp. This one is nothing but initially temp, right? Temp is equal to friend. Is temp is not equal to null? Yes, it is not equal to null. Print its data. 10 is nothing but the data. Okay. Temp is equal to temp tends to next. Now onwards, my temp is pointing here. Sir, is it equal to null? No. What is its data? 20. Print that data. Then make your temp is pointing to here. So what is its data? 30. Is it not equal to null? That's why. So next your temp will become this one. Not equal to temp. Not equal to null. So 40. Next your temp is pointing to null because we don't have any other nodes right at the last. That's why null. Then it will stop. So these are the elements present in the queue or not? Yes. This is nothing but how you can able to implement a normal queue display function. I'm explaining only display function. So later I will talk about how you can able to perform insert operation and how you can able to perform delete operation. Okay. Sir, can you please confirm is the concept is clear for you people? Everyone, is it clear? Right, sir. Now, sir, I need to go for insert function. Sir, can you please insert the object into this queue? So void, I am taking the function name as insert. It will take integer value. Suppose first I will create the, okay, first I will create the node. New node is equal to, so new node with a given value, okay, with a given value, and then, sir, I'm going to give the next field as a null, like this. Suppose if your friend is equal to null and rare is equal to null, that means if we don't have any nodes, then what we have to do? Your friend will become new node and your rare will become new node. Correct, right? Because that is the first element. Otherwise, what will happen? Anyway, I will write that instruction. So then size plus. Okay, sir, have a look once. Have a look once. I will take the diagram. Sir, consider initially we don't have anything. If you don't have anything, sir, your front and rear both are pointing to null or not? Yes. Now the node which we have created will become new node. This is nothing but a new node what we have. So consider the data is 11 and this one is the next node and this node will become new node. You can see your front is equal to null. Yes, your rear is equal to null. That means this is the empty queue what we have. Then I am assigning front and rear. Both are pointing to new node. Sir, these links will be gone. Now your front is representing this node and your rear is also representing this node. Like this we have. Sir, I have already one node is there. Okay. So after this insertion, this is the node what we have 11. So this will become front node. This will become front node and this will become rear node. Okay, like this we have. Okay, right, sir, 1 second, please wait. Yeah, right, sorry for the delay. So like already I have some node is there. So then what will happen? Sir, I'm going to create a new node here. This will become a new node. So next field is as usual null and the name of this nothing but consider new node. So content is it is a since it is a queue data structure, what we have to do? We need to connect these nodes, right? We have to connect these nodes. Sir, we need to move this where pointer to point here. Okay. And then you have to remove this node. We have to connect these two. Only two instructions. One is establishing this link. Second one is nothing but changing this. So that I'm doing here. Already your array is there. Its next field is pointing to new node. Then your rear will become new node. That's all. These are the two instructions what we have to write. So first, this is the rear, right? Its next field will become new node and rear is equal to new. Consider I want to insert one more element. New node will be created here. The name of this node will become new node. So next field is null. Consider the content is 13. So now is your rear or null? No. Then rear tends to next. Next field is pointing to new node and your rear will become new node. Okay, like this we have. Like this keep on we can add the contents. This is nothing but how to perform insert operation on normal queue. Can you please, is this insert operation logic is clear for everyone? Please confirm. Is it clear for everyone? Please confirm, guys. Right. Good, good. It's so now, yeah, is it clear now? Right. Sir, now we will see delete operation. How you can able to perform delete operation. Okay. So I'm taking void. So delete operation I'm taking. So integer, I think we are not required to pass any values. We are not required to pass any values. So now I'm checking is my queue is empty or not. Sir, when we can say my queue is empty? If your size is equal to I'm printing the message saying, so my queue is empty. Like this I'm taking and will return. Sir, otherwise what will happen? System dot out dot print ln of so deleted item is which item is deleted. So you deleted item is nothing but I'm taking friend dot. So then immediately your friend will become friend dot next and size point I'm ready to minus. That's all. This is nothing but you can able to perform operation, delete operation. Okay, right. So let us okay. Now sir, consider I have certain nodes up there here. So consider this is nothing 11 one node, and this is nothing but another node what we have like 22, and this is nothing but another node what we have, okay, which is nothing but thing like 33 like this we have, and this node is null and it is pointing to this one and this one is pointing to this one. It will become front and it will become rare like this we have. Now I want to delete. Sir, what we have to do? Is your size is equal to 0? No, no. Sir, is my screen is visible? Can you please, is the delete operation? Yeah, right. So with this, I will stop, sir, because some lagging is there. Yes, yes. So with this, I will stop, please. Okay. Tomorrow onwards, there won't be any issue. Hmm. Now, sir, I am taking system.out.println of the deleted item is which item is deleted? Friend data, that is nothing but 11 is deleted. Okay, so 11 is nothing but deleted. Sir, now what is happening? Your friend is equal to friend dot next. Now onwards your friend is representing this one. Okay, now onwards your friend is representing this one, so that this node is by default eligible for garbage collection. Okay, so this is the way how you can able to perform delete operation. Is this a simple delete operation on circular queue? Okay, yes, yes, we are moving front first in first. Sir, clear up to this? Please confirm everyone. Is it clear up to this? Right, sir. So we will see the execution process of this particular circular queue, sorry, normal queue. Okay. Now create object. Sir, what is the class name we have here? NQ list. N list. So Q is equal to so new NQ list. Sir, immediately I am asking, Are, can you please show your elements? So it will display Q is empty because we don't have any elements. That's why it is going to display like this. So Java C, I'm taking, so test.java, the code compiles fine, and even Java space test, you can see my normal queue is empty. So I want to add some objects into this queue. So q dot insert of 111, q dot insert of 222, so q dot insert of 333, like this I added. Now what will happen? So the objects, first inserted object, second object, third object, like this we will have, right? Now I want to perform delete operation. So q dot, if you perform delete operation, which object it is going to remove? Not 333, 311. So deleted object is 311, and we are getting like this. Sir, still two more objects are there, right? So I want to delete one more object. No problem, you can delete. So q dot delete. Then 222 will be gone, and we have only one object will be there. That is 333. Okay. So now I want to delete that object also. Sir, in the display somewhere we are writing code by using print. After coming out from this function, better to bring new line character, so that we can see line by line instructions. Yes. Now we have only one node is there. Sir, I want to delete that node also. Now q dot, I am taking delete. Sir, what will happen? So it is going to display q is empty because we don't have any elements, right? Like that. So I think you people got very clear clarity about normal queue implementation by using linked list. Can you please confirm? Is it clear? Right. Right. So anyway, the remaining things I will discuss tomorrow, sir, because some lot of disturbance is there in the network. So already I explained a circular queue by using this. Tomorrow circular queue by using linked list and then DQ. Okay. Previous notes I updated. If not, I will update now itself. You can download. Okay. Right, sir. Thank you. Yeah, and the plan for this weekend, we are taking one special class on Saturday or Sunday that I will inform you. No, no, no. For hash table, stacks will be covered in this week itself.